welcome to True Projects. In this video, we are going to explain about a project titled Plant Disease and Pest Detection using the deep learning based features. The plant disease can lead to the significant economic, social, and ecological losses. Detecting and diagnosing these diseases early is crucial to mitigate these negative impacts. Conventionally, botanists and agriculture engineers manually identify the plant diseases, a process that consumes the time and requires considerable labor. To address these novel technologies like machine learning and image analysis are being developed to automate the disease detection. Implementing these technologies hold the promise for enhancing the efficiency and accuracy of early detection and diagnosis. The advancement of these technologies is of utmost importance for the agriculture sector future. By reducing the losses caused by the plant diseases, these innovations contribute to food security and uplift the livelihood of farmers. Plant diseases exhibit the diverse symptoms such as wilting, leaf spot, and fruit rot triggered by the various pathogens like bacteria, fungi, and viruses. Prompt detection and diagnosis enable the timely treatment and prevent the disease spread. By automating the detection process, these technologies revolutionize the field, making it more efficient and precise. And the objective is to detecting the plant disease as a critical task in agriculture to prevent the productivity loss and minimize the crop damage. Machine learning and deep learning techniques have been employed to tackle this challenge. In this study, we assessed the effectiveness of 9 deep neural network architecture for plant disease detection. We utilized the transfer learning and deep feature extraction methods to adapt these models to the specific problem. Subsequently, we employed support vector mission, extreme learning mission, and k-nearest neighbor algorithm to classify the extracted features and real disease and pest images from Turkey contributed dataset for the experimentation. Remarkably, the ResNet 50 architecture demonstrates the best performance among the evaluated model. The studied neural network architecture includes LXNet, VGG16, VGG19, ResNet 50, ResNet 101, Exception, ResNet 152, Inception V3, Inception ResNet V2. Transfer learning allows leveraging the pre-trained models as a starting point for training the leading to the time and effort saving. The deep feature extraction involves obtaining the valuable features in the deep neural network and models, which are then used for training and classifier. SVM, ELM, and KNN are the distinct machine learning algorithms employed for the classification purpose. These are the basic requirements that are required to build this project. Software requirements: Python IDE with version of 3.7, Anaconda with version of 3.7, or Jupyter or Google Colab. Hardware requirements: operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know the flow of the project, the first step is importing the libraries. In this module, the necessary libraries like NumPy, Pandas, Matplotlib for data handling, visualization, as well as deep learning libraries such as TensorFlow, Keras are imported to support the task. And the second one is exploring the dataset. The dataset containing the images of different plant classes is imported and properly structured with appropriate label for each image. These images be organized into folders where each folder represents a specific plant class. And the third one is data pre-processing. Before extracting the features, the images need to undergo the pre-processing, which includes resizing, normalization that make compatible with the deep learning models. And the fourth one is splitting the data into the train and test. The dataset is divided into the training and testing set to train the model and evaluate the performance accurately. And the fifth step is feature extraction technique. These steps involve the using pre-trained deep learning models like ResNet 50, GoogleNet, ResNet 101, Inception, ResNet V2, VGG16, and VGG19. The first one is ResNet 50 is a deep convolutional neural network with 50 layers. It shows the remarkable performance in various image-related tasks, including the image classification. And the second one is GoogleNet. It is also known as Inception V1, as a deep convolutional neural network known for its computational efficiency and accuracy. It uses the Inception module, which employs multiple filter sizes in parallel to capture the features at different scale. And the third one is ResNet 101. Is an extended version of ResNet 50 containing of 101 layers. With more layers, it can potentially capture the more intricate and detailed feature from images. It is particularly useful when dealing with the complex and varied data sets. And the fourth one is Inception ResNet V2. It combines the element of both the GoogleNet and the ResNet architecture. It incorporates the residual connection along with the Inception modules, creating a powerful and efficient network for feature extraction. It is capable of capturing the multi-scale features and can be useful in detecting the fine-grained pattern in the images. And the fifth one and the sixth one is of VGG16 and VGG19, or of popular convolutional neural network architecture known for its simplicity and uniformity. They both have a stack of convolutional layers followed by the fully connected layers. These models are capable of extracting the deep and rich features from the images, making them suitable for various image classification tasks. And the sixth one is building the model. Here, after extracting the features, various machine learning algorithms like extreme machine learning, support vector machine, and k-nearest neighbor are applied to train and classify the image data. The first one is extreme learning machine. It is a machine learning algorithm that is known for fast training speed and good generalization performance. In ELM, the hidden layer weights and biases are randomly assigned and the output weights are computed analytically. This makes the training process efficient and less prone to overfitting. ALM has been used successfully in various classification tasks, including the image classification. And the second one is support vector machine. It's a powerful and widely used supervised machine learning algorithm for classification tasks. SVM works by finding the hyperplane that best separates the different classes in the feature space. It aims to maximize the margin between the classes while minimizing the classification error. SVM is known for its ability to handle the high-dimensional data and is effective in dealing with non-linear relationship between the features. And the third one is k-nearest neighbor, is a simple and initiative algorithm for the classification task. In KNN, the class of new data point is determined by the majority class among its k-nearest neighbor in the feature space. KNN does not require the explicit training. Instead, it stores the entire dataset and calculates the distance between the data points during the prediction. It can work well with small and diverse datasets too. And the seventh step is transfer learning. Transfer learning employs to leverage the pre-trained model on the large dataset and adopt them for plant disease and pest detection with limited data. Here we include AlexNet, VGG16, ResNet 50, ResNet 101, Inception V3, Inception ResNet V2, SqueezeNet, GoogleNet, and MobileNet. And the first one is AlexNet, is a pioneer of the deep convolutional neural network and consisting of 5 convolutional layers and 3 fully connected layers to demonstrate the effectiveness of the deep learning in the image classification task. And the second one is VGG16, is also a deep convolutional neural network which are consisting of 13 convolutional layers and 3 fully connected layers. And the third one is ResNet 50, is a variant of the ResNet architecture containing of 50 layers, and the key innovation is the use of residual block, allowing for much deeper network without suffering from the vanishing gradient problem. And the fourth one is ResNet 101, is a deeper variant of the ResNet architecture containing of the 101 layers. It uses the residual block to facilitate the training of very deep networks and suitable for complex and the challenging visual recognition tasks. And the fifth one is Inception V3, also known as GoogleNet V3, is a deep neural network introduced of concept of the inception module, which use multiple filters of varying sizes to capture the different patterns in the input. And the sixth one is Inception ResNet V2. It is an extension of Inception V3 architecture, combining the idea from the Inception and the ResNet model. It employs residual connection within the Inception modules to further improve the performance. And the seventh one is QuizNet. Is a lightweight convolutional neural network designed for the efficiency and small memory footprint. It employs the 1x1 filter to reduce the number of parameters and computations while maintaining the high accuracy. And the eighth one is GoogleNet. It is also known as Inception V1. Is an earlier version of the Inception architecture developed by Google, and its concept is of using the multiple filters of having the various sizes. And the ninth one is of MobileNet. Is a lightweight deep neural network architecture designed for the mobile and embedded devices with limited resources. It employs depth-wise separable convolutions to reduce the number of parameters and computations. MobileNet is optimized for speed and efficiency while maintaining the reasonable accuracy. And the eighth one is of training the model. Here in this module, the trained model is using the training data and its performance is evaluated. And then the user gives the input. A web interface using the Flask allows the user to input the images of the plant disease and the pest detection. The given input is pre-processed and the trained model is used to predict the presence of disease or the pest. The given input is pre-processed for prediction. At this stage, the input is pre-processed and the training model will be ready to take this pre-processed input. Trained model is used for the prediction. At this stage, the trained model takes the pre-processed input and predict the presence of the disease. And the last one is final outcome is displayed. The final prediction is displayed to the user by providing the information about the plant health status and the potential disease or the pest detected. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The dataset folder consisting of different folders. Within each folder contains of the various plant images. And the model folder consisting of H5 files which contain the algorithm information, and it is loaded at the time of execution of the project for doing the certain task of prediction of the new data within it. And the sample folder contains of the different folders. Within each contains of the images of the plants within it. And the static folder contains of CSS, JavaScript and Bootstrap files. And the template folder containing of HTML documents which contains of after, home, index, notebook, sign in and sign up. And the app.py file likely contains information related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is a IPYNB file. It is a Jupyter notebook which contains the combination of code, graphs and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the sixth and the signup.db as a file appears to be the database file used to store the user information. And for the execution of the project, we need to open the web application, and that before the overall code consisting of drafts, outputs, training, sampling all are present in the Jupyter notebook, and by the web application we are only giving the features that are used and the output that to be displayed for this project. For the execution of the project, first we need to copy this code folder address and open the command Anaconda prompt. And here we get a screen of Anaconda prompt, and we need to change the disk because our code folder is present in the app disk. That's why I'm changing this disk location by writing this command, and then write the other command cd space paste this code folder address in it and click on enter button. And by this we write the another command that of python space app.py. Here this command is used in the command prompt to Anaconda prompt to execute the Python script and perform a runtime check for any syntax errors and logical issues, and then click on enter button. By this, the app.py file is running. The Flash framework will host the application locally at the default address as of like this, and we need to copy this local link provided by the framework and paste it on any web browser, and I prefer to choose of Chrome. I'm selecting this and opening the folder and pasting this local link and click on enter button, and we get an home screen like this. And click on login button. Here we get of login screen, and also we can see of sign up button here. It is used to initiate the registration process. By clicking on it, it will take to the registration page where you can provide the necessary details to the create and new account. My account is already generated. That's why I am moving to the login page and entering my username and password as of admin and admin, and click on login button. By this we redirected to this page contains of home notebook and sign out HTML files, and use some detailed information within that pages. Notebook page contains of the Jupyter notebook file contains of code within it, and the home page is this page, and the sign out will sign out from this web application. And here we need to choose file button, and here it redirected to this folder, this sample folder containing of the different files in it, and select any one of it and click on this any on one of the image and click on open button, and then click on upload button. By this it redirected to that page. Your prediction as uploaded image is of pest detector as Arvinia, and we need to try with another pictures. Click on try again button and click on choose file button and choose any one of this folder and click on it and select any one of images and click on open button, and then click on upload button, and the redirected page is of this. The predicted image is of walnut leaf mitga pest. In this way we can detect the plant disease and pest detection using the deep learning based features. The conclusion: the deep feature extraction and the transfer learning are used to detect the pest detection and the plant disease. Deep feature extraction involves extracting the features from a pre-trained deep learning model, while transfer learning involves fine-tuning a pre-trained model for a new task. The project found that the deep feature extraction produced the better results than the transfer learning. The best results were obtained with the ResNet 50 model and the SPM classifier, which achieved an accuracy of the 97%. The project also found that the FC6 layers of the LXNet, VGG16 and VGG19 models produced the better accuracy score than that of the other layers. The results of this project suggest that the deep learning can be a powerful tool for plant disease and the pest detection. Deep learning is a type of machine learning that uses the artificial neural network to learn from the data. Deep feature extractions is a technique that involves extracting the features from the pre-trained deep learning model. These features can be used to train a classifier, and the transfer learning is a technique that involves fine-tuning a pre-trained deep learner model for a new task.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Project's YouTube channel and subscribe.